Hello, my name is Neil, and today I am going to be telling you about a little robotics project of mine. So my plan is to make a robot that goes around your house and mops it. So this will make it easier for you to manage your house, it'll keep it clean, and you don't have to go around scrubbing. So I'm going to be using the Raspberry Pi to do this, and a bunch of other sensors and hats and servos and whatnot that will augment the Raspberry Pi and allow me to do what I want to. So let me show you the robot. Okay, here is the PiCar-V from SunFounder. I believe this is the 2.0 version, and I've made a little bit of changes. So first, there was this camera on some servos here, which allowed it to move around, but I have removed that because it was just big and clunky and I didn't really need it. Maybe I'll add it on later if I need it for navigation. So all the rest of the parts are stock that come with the kit except for this little sensor. This sensor is the B&O 055, and it's a quite nifty accelerometer / gyro sensor. And it does a lot of the calculations that you would normally have to do in code that are very maths intensive to make sure that you account for all the gyro drift and all of those little mechanical problems. It is pretty expensive for a sensor at $35, but there's no point in trying to get a PhD in signal processing and trying to learn all the ins and outs of a sensor to fix it. So getting this B&O is the best option. So now we have this, which is a place to connect the motors to, which are down here. We have this one, which is a modified version of the PCA, which connects to all the servos, like the one for the drivetrain. Here is the hat, which kind of wires everything together and makes sure that the batteries, which are actually 6 volts, don't fry the Raspberry Pi. And then right under it, over here, we have the Raspberry Pi itself. So now let's get to the code. So here I have logged on to the Raspberry Pi via a VNC. This just allows me to use my computer's keyboard, mouse, and display to interact with the Raspberry Pi. So here I have written a script, and this allows me to turn the Raspberry Pi with actual degree measures. So I can turn the Raspberry Pi by 90 degrees, 45 or whatever, and it allows me to make sure that when it's going straight, it will keep on correcting the motor's drift and will stay in a relatively straight line. If I don't use the gyro sensor, the B&O sensor that I've added here, then it will drift because no motors are perfect. Okay, so here I've just imported some libraries for the gyro sensor, the PiCar, threading, and datetime. So I have this function, straight thread, and this is the one that allows me to go straight. So what happens here is it starts adjusting, it just prints this message, and then it goes in a while loop. So it keeps on going in this while loop while turn stop equals false. And this is useful because then when I want to stop it, I just call my stop function and it will make the turn stop variable true, and this will shut off. So what this is doing is it's just repeatedly checking the angle and correcting it to make sure that it goes straight. And we'll see that in action later. So further down, we can see turn by angle. And this doesn't need to be done in a thread because we don't need any separate thread to change the stop value, right? So here we're running a thread continuously, and when we call stop in a different thread, then the thread that's running everything will notice that and stop. But we don't need this by turn by angle, because we know once we hit that angle measure, we're done. No exceptions. So here what we're doing is we're just figuring out which direction we're turning, turning the wheels in the angle servo direction, which I've done to 30, because if you turn it too sharply, it can cause a bunch of complications and make it slide and that sort of stuff. And we're running a while loop, and which will stop once the angle is whatever we want to reach. So what will happen basically is we set the angle of the servo, right? So it will turn like this. And then it'll keep on turning. And once it reaches its desired angle, let's say 90 degrees, then it's going to stop out of the while loop, straighten these wheels, and end the function. So here, it just returns the sensor, because after you go here, you want to reset the gyro sensor so that if you want to go forward again, it doesn't think, oh, we're 90 degrees off, and turns back this way. So now we have go straight time, where I'm just putting my straight thread into an easy function for me to use. And over here, I've written a try catch loop, where essentially using those two functions, I go in a square. So it goes forward for 5 seconds, then it turns 90 degrees, goes forward for 5 seconds, turn 90 degrees, and that keeps on repeating. And I've put it in a try catch loop because whenever I want to, I can just do Control C, stop the program, and in the accept, it will turn all of the motors off in the servos, and it'll stop with the loop. So now, let's look at the test. So now that we have some open space, I can actually show you what this square looks like, and I can show you some of the corrections that the go straight will do. So let's just go here, go to the directory, just walk over there, go Python 3. All right, and let's just run the script. All right, now let's just run it. Okay, there we go. We start with a turn, then we're going forward now. Oh shoot. Okay, it's run out of space. Okay. So as you can see there, it does actually turn by 90 degrees. So now let me show you how the go straight function actually works in real time, and I'll show you some of the corrections it's made. It's pretty neat. All right, let's put this here. Let's do these brackets, and now it's just gonna continuously go straight. Let's save that actually. Just minimize that since we're not using it. Right, let's just run that again. So now, okay, as you can see, it's doing some corrections. And now, if I turn it this way, you can see that actually it's turning its wheels, and then slowly the wheels will level off, and this way it actually goes relatively straight. So now, so this allows me to accurately control the robot and not have any drift, because without this, it will go off to one side consistently, and there's nothing I can do about it. So all of this code is a great starting point and allow me to have a solid base for the navigation of the Mopper robot. So what I wanted to be able to do is have a few extra sensors and have a place like this and just keep on mopping it, maybe even go over here and mop that bit, and having, having accurate control will really be beneficial in properly controlling to the robot. Now to the outro. So there we go. We've got a solid foundation to make this Mopper robot. We are now able to go in a properly straight line and do turns by degrees. This will be massively beneficial when we do the navigation. And in the next video in this series with the Mopper robot, I will be most likely working on obstacle avoidance and creating a better chassis, because right now this isn't perfect. Obviously, it's a widely created product and there's still some things that could be improved, and it would be good to change it for our purposes. So I'll see you in the next video. Make sure to like, share, and subscribe, and bye for now.